Okay, the next video lecture, problems on the slip, that is induction motor chapter. The first problem, a 3-phase 50 or 6-pole induction motor has a full load, percentage of slip is 3%, find the synchronous and actual speed. This is also exam problem, January 2003, 4 marks. First, write down the given data, the frequency is 50 Hz, pole is 6, slip is 3%, that is 0.03. First, you calculate synchronous speed, ns. What is ns? 120 f by p. Just substitute the f value and p value, we get ns. 120, 50 by 6, that is 1000 rpm, that is synchronous speed. The second one, you calculate slip, s equal to ns minus n, ns into 100. Percent of slip equal to ns minus n divided by ns into 100. That is n. Using this formula, you separate n equal to ns 1 into s. What is ns? Synchronous speed. Just now calculate 1000, 1 minus 0.03. Next you find n equal to 970 rpm, that is actual speed. The second problem, an 8-pole alternator runs at 750 rpm and supplies the power of 6-pole induction motor which runs at 970 rpm. What is the slip of the induction motor? This is also exam problem, January 2015, 6 marks. Just write down the given data. Here the alternator induction motor. First alternator, P equal to 8, ns is 750 rpm, that is alternator. P equal to 6, n equal to 970 rpm, induction motor. First you consider alternator, ns equal to 120 f by p. First you calculate frequency. F equal to 750, ns is 750, p equal to 8, that is 120, that is 50 Hz. Frequency is 50 Hz. Next for induction motor, ns equal to 120 f by p, 120, f is 50 by 6, that is ns is 1000 rpm. Using ns and n, you calculate slip. The slip equal to s, ns minus n divided by ns into 100. The 1000 minus 970, 1000 into 100, that is 3%. Okay, next problem, problem number 3. This is also exam problem, asked several times. August 2006, July 2008, June 2010, that is 5 marks. The 10-pole induction motor supplied by 6-pole alternator which has driven at 1200 rpm. If the motor runs at slip is 3%, what is the speed? Here also two cases, one is alternate, another is induction motor. Alternator, ns equal to 120 f by pa. Pa equal to, we consider as alternator with respect to the alternator pole. Alternator pa equal to 6, ns is 1200 rpm, already given in the problem. Induction motor, the pole is 10. First you calculate frequency, 1200, 6, 120, that is 60 Hz for alternator. Next for induction motor, the slip equal to ns minus n, ns, and first you calculate ns, 120 f by pm. Because ns is not given in induction motor, you calculate ns. ns equal to 120, frequency is 60 divided by 10, that is 720 rpm. Using ns, you substitute the ns minus n, ns, that is you substitute the slip formula. Slip is 3% already given, ns is 720, and as it is, because n is calculated, 720 ns, you get easily get n. n is 698.4 rpm. Next problem number 4. An 8-pole alternator runs at 750 rpm, supplies power to 4-pole induction motor. Frequency of rotor is 1.5 Hz. That is FR is, rotor current frequency FR is 1.5 Hz. What is the speed of motor? What is the slip? Here you calculate speed and slip using rotor current frequency. It's also example from 2007 August, January 2015, 4 marks. First alternator, PA equal to 8, ns is 750 rpm, induction motor PM equal to 4, frequencies FR is 1.5 Hz, already given in the problem. For alternator, ns is 120 f by p. First you calculate f, 750 ns, 120 f by 8, f equal to 50 Hz. Next for induction motor, FR equal to s into f. FR is 1.5 Hz, already given in the problem. S as it is, s is calculated, frequency is 50. S slip equal to 0.03, that is 3%. That is ns equal to 120 f by pm. 120, frequency is 50, pole of induction motor 4, that is 1500 rpm. Using this ns, you calculate n equal to ns 1 minus s. ns is 1500, 1 as it is, slip is 3%, that is n equal to 1455 rpm for speed of the motor. Slip is 3%, speed of the motor 1455 rpm. Stop the video.